Hello, and welcome to the first video in the Algebra 2 playlist that I'm starting. If this is Tarun, hey buddy. If this is anyone else, have fun. I have created this playlist for one of my friends, but everybody can listen to it because I like educating people. Okay, since this is Algebra 2, I'm not going to do anything from Algebra 1 other than quadratics, because quadratics are extremely important, and they could have been forgotten over the summer. About, like, half of Algebra 2 and most of calculus requires knowledge of quadratics. The first way to solve a quadratic that I will teach you is simple algebra. Let's say you have been slacking in class, little troll. So, let's say the teacher notices that you've been slacking, and it gives you this problem. 3x squared minus 15 is equal to 12. Well, somebody who doesn't listen to my videos will be screwed. Somebody who does listen to my videos is going to walk up to the board and boss this question. Now, since we're trying to solve for x, which is what most teachers assume, we want to get rid of this minus 15 and put it on that side. Actually, we want to get rid of everything except for x on that side, and then solve for x. So minus 15 and plus 15 cancel, and 12 plus 15 is equal to 27, and this side is still 3x squared. Now, we want to continue by dividing everything by 3, so we can get the x all alone. Maybe 3 is going to be 3. So that's x squared equals 27 over 3. 27 divided by 3 is equal to 9. Now, the square root of something, so let's say the square root of 9, just finds the number that if multiplied by itself is equal to 9. So what number multiplied by itself, you can take a look at the multiplication table, so 1, 2, 3, 4, 1, 2, 3, 4. 1 times 1 is 1, 1 times 1 is 2, 1 times 2 is 2, 1 times 3 is 3, 1, 2, and then 4, and then 6. This should be 3, 6, and 3 times 3 is equal to 9. Now, we're trying to find a number that if multiplied by itself equals 9. Well, here it is. It's 3. 3 times 3 equals 9. So that means that the square root of 9 is equal to 3. Now, that means that 3 times 3 equals 9. Here's a little catch to quadratics that many people forget, and that's why they fail on tests, even though they can solve the quadratic properly. Think about negative 3 times negative 3. A negative times a negative is just a positive, and 3 times 3 is 9. That's positive 9. So 3 times 3 and negative 3 times negative 3 both equal 9. So whenever you're taking the square root of something, so let's say you have 9, you're taking the square root of it, you have to add a sign that says plus or minus 3. Because both 3 multiplied by itself equals 9, and negative 3 multiplied by itself equals 9. So I have to clear that up. So now all I have to do is just take the square root of both sides, because when you take the square root of something, it gets rid of this squared. And if you have, let's say, rad x, let's say the square root of x, you can also say rad x instead of that. If you square the square root, which is also called a radical, you get rid of the radical, and these cancel out, and you get x. So if we take the square root of something squared, it just becomes itself. So x equals the square root of 9, I was talking about that, is plus or minus rad 9. X equals plus or minus 3. So, let's see. We could plug, let's see, plus 3 into the equation. So we get 3 times 3 squared minus 15 equals 12. Does that equal 12? Let's see. What is 3 times 3 squared? That's 3 times 9. 27 minus 15, you should be able to do that in your head, is 12. So 12 does equal 12. So this is correct. Let's take, for instance, negative 3. So it's going to be 3 times negative 3 squared minus 15 should equal 12. What is negative 3 squared? We talked about it just now. That's 9. So that's 27 minus 15 is 9. Is 12. So 12 is 12. And that is also correct. So this answer right here is correct. Okay, let's move on to another question. Remember that practice makes perfect. 5x squared plus 3 equals 128. Well, Mr. Algebra, well, how do we solve this? This is big numbers. Well, remember, we have to get rid of this constant term first. So we have to subtract 3 on both sides. And what do we get? We get, I want a different color. This is boring. Aha, coral. What an amazing color. 5x squared is equal to 128 minus 3, which is 125. Now, we have to divide both sides by 5. Most of you should know by now that 125 divided by 5 is equal to 25, but we will do the long division to prove it. So 125 divided by 5. 5 goes into 12 2 times. That's 5. That's 10. 2, and then 5 goes into 25 5 times. Team Fortress 2, I do not care. Okay, so x squared equals 25. What do you know? 5 times 5 equals 25. Now, so we can take the square root of both sides. So we take the square root of that and square root of that. So that just becomes x, and remember you have to take plus or minus rad 25, which is in fact plus or minus 5. And if we were to plug in 5, we'd get 5 squared. 5 times 5 is equal to 5 squared is equal to 25. 5 times 5 is equal to 125 plus 3 is equal to 128. Go away, cat. Nobody likes you. Okay, so on with the show. And if we were to do that with negative 5, we'd get the same thing. Now, I'm going to give a harder problem. Okay, so we're going to square root of 3x minus 2 squared plus 5 is equal to 8. Now, remember I had said, if you have rad x and you square it, the radical and the squared cancel out and you just get x. So, we're going to just take the square root of both sides. Square both sides. Square 8 squared. What is 8 squared? That is 8 times 8. And that is 64. You should know that by your tables. So, let us continue. 3 times x minus 2 squared, remember we got rid of the radical, plus 5 is equal to 64. Let's subtract 5 from both sides. So minus 5, minus 5. 3 times x minus 2 squared is equal to 64 minus 5 should be 59. That is not pretty, but we'll have to continue. So we're going to divide both sides by 3. Oops, that wasn't supposed to happen. Divide by 3. 59 thirds is going to stay 59 thirds. Sadly, you cannot simplify that. So you get x minus 2 squared. This is all squared. Is equal to 59 thirds. Now, let's say you have x plus a squared. The square root of x plus a squared, remember these just cancel out, is equal to x plus a. In this case, r plus a is negative 2. So we're going to just take the square root of both sides, and we will get that x minus 2 is equal to plus or minus rad 59 over 3. Right now I'm going to have to teach a few radical identities if you don't already know them. Let's say we have rad A times rad B. Rad A times rad B is equal to rad A times B, which can be rewritten as rad AB. Rad A divided by rad B is equal to rad A over B. So, what do we know? Well, let's take the inverse of that. So that means that rad A, rad A over, no, sorry, rad A over B is equal to rad A over rad B. So we had rad 59 over 3. So that becomes rad 59 over rad 3. Now, in mathematics, you're not allowed to leave a radical in a denominator. The denominator has to have a whole number in it. So, rad 59 over rad 3. What are we going to do with this? We're going to multiply it by the radical in the denominator over itself. So, it's going to be rad 3 times rad 3. You're saying, well, you can't multiply a fraction if it's not in an equation because that's just not allowed. Well, remember, what is anything over itself except for 0? Anything over itself is always equal to 1. Anything times 1 is itself. So, what can we say? Oh, that's just multiplying by 1. That's totally allowed. It's just manipulating it. So that's 59 times, rad 59 times rad 3, and because we have this, we can say that's the same thing as rad 59 times 3. So what is rad 59 times 3? According to my calculator, that's rad 177. What is rad 3 times rad 3? Well, the square root of x times the square root of x is equal to x. So that's going to be just 3, because rad 3 times rad 3 is just 3. So, what can we do now? Well, we know that x minus 2 is equal to plus or minus rad 177 over 3, because we rationalized that and got to this. So, we'll do our final step, and we'll get x, and we're going to add 2 on both sides, get x equals 2 plus or minus rad 177 over 3. And right away you can see this isn't very pretty. But if you were to put that into the original equation, right here, you would get 8. No matter what. 2 plus rad 177 over 3 and 2 minus 1 rad 77 over 3 both solve the equation correctly. By the way, most quadratics are written in the form ax squared plus bx plus c equals 0. When you're using simple algebra, this term doesn't exist, or else you can't use simple algebra. Or if you have something like a times x minus b squared plus c, you can use simple algebra. We just proved that you can use it right here. So, that finishes my presentation on simple algebra. Thank you.